Hello, today I'm going to be explaining how to do systems of equations using Desmos. So on the SAT, uh, on the new digital SAT, you can use Desmos. And this is really helpful because for a lot of problems, it's a lot quicker to use it. And for a lot of these systems of equations problems, it's actually quicker to use Desmos and to actually do the equation out by hand and actually solve it yourself. So today I'm going to be explaining that. And as always, don't forget to like this video and don't forget to subscribe as always. So let's get started. So let's say for example we have certain system of equations. Let's say we have something like 2x plus 3y is equal to maybe 15. So as we can see, I entered this into so in Desmos there's usually on the side there's like an area where you can enter equations or anything in or calculations. And in this case, I entered in this this equation, 2x plus 3y equals 15, and it just graphs this equation. And as I'm sure you guys know, if you guys watch my video about what systems equations are or have any prior experience with it, you know that systems of equations, um, they're basically just two equations of lines or graphs. So in this case, the graph for 2x plus 3y equals 15 is a line like this. So that's why the graph looks like this. And then let's say we have another equation called um, let's just say it's maybe 4x plus maybe 5y is equal to maybe 12 or not 12. We'll make it something like 18 there. So now, as you can see, we have this red we have this red line which is meant to show this top equation, this 2x plus 3y plus 15. It's the graph for that. And then we have this bottom 4x plus 5y equals 18. So these are the two equations, and as these are the two lines, and as you can notice, these two lines they intersect each other at this point, and Desmos is actually really nice because it gives you the points of intersection. In this case, it's saying exactly where they intersect. It's saying they intersect at negative 10 and a half and 12, and this would be the answer. The answer to this system of equations would be negative 10 and a half and 12. And the reason for this is because wherever two graphs, wherever two graphs touch each other, wherever two graphs cross each other, that's called the solution to uh, those graphs. So in this case, the solution to the system is basically be where the two graphs touch each other. So for any system of equations, no matter what it is, if uh, if the two graphs, or if even if you have more than two equations, no matter where they are, if they intersect anywhere, that's the answer. That's the solution to the system of equations. So in this case, it was really easy to find. We didn't have to do any solving. All we needed to do was put in both equations into Desmos, and it gave the answer negative 10 and a half, 12. And we can even do that if I add another or if I add something like if I change this equation to something like a parabola. So let's say I make it x squared maybe plus 4y. Sorry, plus 4 is equal to um 2y or something like that. In this case, as you notice, there's this parabola. In this case, there would be two answers to system of equations. There would be this answer over here, these two long decimals, and this other answer over here, these other two long decimals. And usually, whenever you have a problem like this, whenever they're multiple choice, you can do this and just find whichever answer is the same as these decimals. So again, remember it's important to remember that you can use Desmos only on the SAT, and you can basically graph both equations and then find where the equations intersect, and those are the solutions. Thank you so much for watching, and I hope to see you on our next video. Thank you.